everyone! This is just a short instructional video to show you how to complete the balancing chemical equations simulation in lab. The first thing you're going to do is answer these pre-lab questions. And so I'm going to actually go over them together. So when it says what number represents the coefficient, remember that that's the number in the front here. So in this case, that would be a 5. And then when it says what number represents the subscript, that would be this 2 here, the number at the bottom. Then it asks what element is represented by the H. So H, we should all know by now, that is hydrogen. And then it asks how many H's do we have? So we take this 2 and we multiply it by the 5 out front to tell us that we have 10 hydrogens total. Okay, then the next thing you're going to do is you're going to go through a simulation. So I've attached the link in Canvas, so you can just click on it there, or you can Google PhET balancing chemical equations, and then you'll click on the very first link that shows up. And then it should pop up with something that looks like this over here, and then you'll click that play button in the middle, and it should show you there's an introduction and there's a game. So you want to click on the introduction first. And then just kind of play around with it. Explore the simulation, click on everything. There's some balance scales and there's some bar charts. So you can find those under tools and then figure out just which one you like the best. And then tell me which one you selected and what they are helping you to do. Then you're going to start learning how to balance equations. And so you're going to start off looking at this first one that has nitrogen and hydrogen that are reacting together to make nitrogen trihydrate or ammonia. And I want you to use the tools, visually and see, is this equation balanced? So you can see visually whether or not the equation is balanced using this simulation. You can also go through and do it like we were talking about in the lecture. So explain to me why the equation is or is not balanced, and then change the coefficients until you get a smiley face, and then tell me what the smiley face means. And then explain what happens to the bar charts when the equation is balanced, and then you'll do the same for water. Tell me, is it balanced? So on and so forth. And so you're going to go through the rest of the simulation. When it says here, list all the reactants, remember that reactants are the stuff on the left, and here the products are the stuff on the right. Okay? Once you're done with this part, you can go to the game and practice trying to balance these equations. So you'll start with level 1 and then 2 and then 3, and tell me your best scores and times. This is just mostly so that you get some practice here. Do each one at least once. Even if your score's not great, even if your time's not great, that's okay. Tell me what they are. And then you can move on. You can also come back and do this last if you want to get some more practice balancing equations before you play the games. Then we have kind of like a lab, so we're going to be off of the simulation now, and we have some problems that we're going to do. So this is instructions on how to do these problems in the data table. So I'm actually going to go through them right now, so you don't need to read through the instructions if you don't want to, but they are good for reference. So this is how I want you to fill out the data table. So here, this first one, it says H2 plus O2 gives us H2O. And so we're going to say how many of the reactants we have. So on the reactant side, remember this is always going to be the left side. Right now we have hydrogen and we have oxygen on this side. And we have 2 hydrogens because it says H2, and we have 2 oxygens because it says O2. So then we're going to look at the product side. Remember, this is on the right-hand side. So on the product side right now, we have 2 hydrogens because it's H2, and we only have 1 oxygen, right, H2O. Remember, if there's no number, right, there's no subscript, that's telling us that there's an imaginary 1 there. So as we can see, our hydrogens right now are balanced. We have 2 on each side, but our oxygens are not. We have 2 oxygens on the left, but only 1 oxygen on the right. So our goal would be to then go and balance this equation. So let's say here, I'm going to put this up here. We have H2 plus O2 gives us H2O. And I would go through and actually do this on a separate piece of paper, just so you have room to work. Or if you have a whiteboard, that would actually work really, really well. So I'm going to copy these here. We had 2 and 2 and 2 and 1. So our oxygens aren't balanced. So the first thing that we'll do is we'll add a 2 out here in front of water. And when I put a 2 in front of water, that changes this. And now I have 4 hydrogens. And that 2 also gets multiplied to the oxygens. And so now I have 2 oxygens. So by adding that 2 out front, it distributes to all of the elements in that compound. Now we have our, our oxygens are balanced, but our hydrogens are not. So our hydrogens, in order to balance them, we're going to put a 2 out front here. And when I put the 2 out front, that multiplies by H2, and that gives us 4 now. 2 times 2 gives us 4 hydrogens. And it doesn't go to this oxygen over here because it's being separated by this plus sign. So the 2 only goes to the hydrogen. So now if we look at this, we have our hydrogens are balanced. We have 4 on each side, and our oxygens are balanced. We have 2 on each side. So we're done. So now what we're going to do is we're going to copy down our final reactants, how much we have of each one. So we have 4 hydrogens and we have 2 oxygens, and here we have 4 hydrogens and 2 oxygens. So now we are balanced because we have 4, hydrogens on each side, 2 oxygen on each side. So we'll go ahead and copy down our balanced chemical equation. So we had 2H2 plus O2 gives us 2H2O. So that's that's my proof that I have balanced that chemical equation. Okay, so you're going to go through and do this for all of those equations that we have. So you have, I think, 9 more to do by yourself. These last 2, I'm telling you now, are tricky. Okay, if you ever get into a point where you're a little bit stuck and you can't figure out how to balance it, my recommendation to you is to go through and put a 2 in front of something. Specifically, the very first compound. So like if you get stuck, put a 2 in front of H2O2 and put a 2 in front of C2H6. That's just a really good way to kind of get unstuck, okay? And then what you're going to do last is you're going to answer this analysis and results page. So what does the arrow mean, right? What side of the equation are the reactants and the products found on? Why do we have to be balanced? Remember, that has to do with the law of conservation of mass, right? We can't destroy or create mass, so we have to have the same amount of each thing on either side of the reaction, right? This is why, magic's not real, right? We can't just simply have something disappear into nowhere. And it says, why can't the subscripts be changed? If you'll recall, right, subscripts save lives. If we have H2O, if we have H2O, that corresponds to water. But if we have H2O2, that means hydrogen peroxide, right? We can't change this number down at the bottom from a 2 to a 1 or from a 1 to a 2 because that changes the compound. Water, you drink it, you live. Water, your hydrogen peroxide, you drink it, you might die. So that's why I always say subscripts save lives. So you can't change the subscripts when you're balancing chemical equations. We can only change that number in the front. And then when it says simplify the equation, that would be like if we had, if we take that, that equation that we had before, that H2 plus O2 gives us H2O. If instead of having 2, 2, and 1, if I had 4, 2, and 4, right, if we look, we have 8 hydrogens on each side, and we have 4 oxygens on each side. So it's balanced, but we can reduce all of the numbers in the front. So that could be a 2, that could be a 1, and that could be a 2 if we went through and divided all of those coefficients by 2. So that's what I mean by simplifying the equation, right? Making sure those coefficients are in the lowest, common ratio. And then in your conclusion, write 2 or 3 sentences on what you learned about balancing chemical equations in this lab. So I hope this helped. Mostly people get stuck on this data table. So I'm going to leave this up if you want to screenshot this or pause it here because people get stuck on what to do on this particular page. As always, if you have any questions on how to do the simulation or the lab, please send me a message. Don't just, be stuck. But I hope you enjoy this balancing chemical equations simulation in lab, and I hope it helps you, really understand what it means to have a balanced chemical equation. So good luck, and I will talk to you guys next time.